Hello everyone and welcome to this video. In our previous video, we studied the fundamental theorem of arithmetic. Now, we will study theorems related to irrational numbers. You all know that real numbers are made up of rational and irrational numbers. Dear children, can you sort these real numbers into rational and irrational numbers? Well done! The numbers in the first column are rational because they can be written as P over Q. And the numbers in the second column are irrational because they cannot be written as P over Q. Let us consider an interesting fact. Let's divide the number 64 by 2. We get 32 as the answer. Can you guess the square root of 64? Absolutely right. It is 8. Is 8 divisible by 2? Yes. If 8 is divided by 2, we get 4 as the answer. If we continue to do the same with other numbers, what do you observe? Based on these examples, we can say that for a positive integer a, if the power of a is 2 and it is divisible by any prime number, say b, then the number a will also be divisible by b. Come on, let us consider the square root of 7, which is an irrational number. Suppose that the square root of 7 is a rational number. Therefore, we can obtain two integers a and b such that the square root is 7 is equal to a upon b and b is not equal to 0. Suppose a and b do not have any common factor other than 1, where a and b are co-prime. By squaring both sides and rearranging, we get 7b square is equal to a square. That means that 7 divides a square. Therefore, 7 will also divide a. Suppose, when we divide a by 7, we get c as a quotient, where c is an integer. Putting the value of a in equation 1 and solving, we get b square is equal to 7c square. This shows that 7 divides b square. Then 7 will also divide b. According to the given irrational number square root of 7, we get two results here. Thus, we know that a and b have at least one common factor and that the common factor is 7. Note that we had assumed that a and b do not have any common factors other than 1. Whereas the opposite or contradiction of this is obtained. This contradiction has occurred because we have made an incorrect or erroneous assumption that the square root of 7 is a rational number. Therefore, we have proven that the square root 7 is an irrational number because we found a common factor other than 1 in a and b. In this video, we studied theorems related to irrational numbers. In the next video, we will see examples related to this.